Hi guys, good morning. So today we'll be discussing the energetics past paper and understanding the concepts behind it and the way of approach. It is one of the most important units among the physical chemistry and the most easiest one. I am Sharaf Amir. Welcome to my channel. The part is a 10th question B part. Sorry, C part. Right. Now see here. So this is the question, right? This is going to be the question. Liquefied petroleum gas, LP gas, is commonly used as a fuel for cooking purposes in Sri Lanka. It is a mixture of liquefied propane and butane, right? Under high pressure. It is a mixture of liquefied propane, liquefied, it is in liquid form, liquefied propane and butane under high pressure, right? The following data are provided. So they have given a table there, and they have given substances as well as the standard enthalpy of formation at 25 degrees Celsius. They have given a standard state there. So they have given for water, carbon dioxide, then for propane and butane here, right? So the first question is calculate the standard enthalpies of combustion of propane and butane at 25 degrees Celsius. Okay. Okay, this is the question here. Now they have asked to give the combustion enthalpies of propane and butane, right? At 25 degrees Celsius. Now see, now I think you guys know the one of the most famous equation is the hydrocarbon combustion, right? Hydrocarbon combustion equation is there. So let's say, like if you have CXHY, once if it reacts with O2, right? It reacts with O2 to give X mole of CO2 and Y by 2 moles of H2O. It's going to be in gas. Difference is going to be in gas. It's also going to be in gas. This can be liquid or gas. Right? Can be liquid or gas. Right. Now see here. This is one of the most famous equation, right? So 1 mole of CXHY reacts with 1 mole of CXHY hydrocarbon reacts with X plus Y over 4 moles of oxygen gas. So it burns. It means it has combustion. So it burns. So therefore, X plus Y over O2 gas under combustion gives X moles of CO2 gas and Y by 2 moles of H2O. Right? Now see here they have given the hydrocarbon number C3H8 and C4H10. So C3 means propane. So propane gas, and then we have butane gas here, right? Now see here, C3H C3H8 plus, now X is 3 and Y by 4, right? Right. So this is in gas state. C3H8. So 3 plus 8 by 4 O2 gas under combustion gives 3 moles of CO2 gas and 8 over 2 moles of H2O liquid. So if you simplify this, by simplifying this, you can get the equation. By simplifying this, you can get the equation. C3H8 gas, 5O2 gas, C3H8 gas, 1 mole of C3H8 gas reacts with 5 moles of O2 gas to provide 3 moles of carbon dioxide gas plus 4 moles of H2O liquid. Right. Now see here. Now see here. Now here in the table they have given, within the table they have given the standard enthalpy of formation of water, carbon dioxide, propane and butane, right? So now see, so they have given per moles here, right? Per moles means for 1 mole. So here you have 1 mole of CH3, C3H8. So the formation enthalpy of C3H8 is minus 104 kilojoule, 1 minus 1. Then for carbon dioxide, we have minus 394 kilojoule mole minus 1. Then for water we have minus 286 kilojoule mole minus 1. Right. Now see here, 1 mole of propane gave completely react with oxygen gas to give 3 moles of carbon dioxide. So for 1 mole of carbon dioxide, the the energy release is minus 394. Since it is 3 moles, that means you have to multiply this one with 3. Understood? You have to multiply this one with 3. So here we have 4 moles of H2O liquid. For 1 mole, this much of energy is being released. So therefore, multiply this one by 4. Right. Let's say this one is delta H theta 1. Right? Let's say this one is delta H theta 1. So for the resultant enthalpy of a reaction can be derived easily here, right? It's like this. So according SS law, right? According to SS law, you have I can give you in a simple way, right? Wait. So formation enthalpy of, so you will get 3 carbon solid graphite here, plus you have 4 moles. So I mean 8 hydrogen means 4 H2 gas here, 4 H2 gas, and you have 5 moles of water gas. So these are elements from the elemental combustion only. You're going to get the propane, carbon dioxide, and the water. So it is easy. So once you see the equation itself, if you see from the left hand side, it is easy to get the elemental composition here, right? So by using a thermodynamic cycle also you can do. Instead of that, you have another method also where I'll say you how it comes. So for the formation of propane, minus 104 kilojoule mole minus 1 is needed. So for 1 mole of carbon dioxide formation, you need minus 394 kilojoule mole minus 1. But since there is 3 moles, so I have to multiply this one by 3. Same way, for the water also, you have minus 286 kilojoule mole minus 1. So since there is 4 moles, so I have to multiply this one by 4. So according to Hess law, right? Like if you like in physics, clockwise moment is equal to anti-clockwise moment. Just in that same way, the resultant must be 0. For the thermodynamic cycle, the total resultant must be 0. So according to Hess's law, in this direction, let's say this one is plus. So delta x theta 1 plus bracket minus 104 kilojoule mole minus 1. This side is plus, no? This side is going to be minus. Minus bracket, right? 3 into minus 394 kilojoule mole minus 1 minus bracket 4 into minus 286 kilojoule mole minus 1, which is equal to 0. This one is going in the clockwise direction, so I took plus. Understood? So delta x theta plus minus 104. Here, this one is in the anti-clockwise direction. The cycle is in the anti-clockwise direction. So minus 3 into minus 394 kilojoule mole minus 1 minus and minus 4 into minus 286 kilojoule mole minus 1. That total must be equal to 0. Understood? So delta x theta 1 is equal to, you can bring all these equations to the opposite side. So if you bring this one is plus, no, plus into minus, minus. So 104 kilojoule mole minus 1. Kilojoule mole minus 1. Plus, right? Plus. Here you are going to have minus into minus plus. If you bring to the opposite side, minus. If you simplify this, so 1182 kilojoule mole minus 1 minus 4. So minus 1144 kilojoule mole minus 1. So delta x theta 1 is equal to, so the answer is going to be minus 1222 kilojoule mole minus 1. Right? The answer is going to be minus 122 kilojoule mole minus 1. If you think of propane, for propane here, we have written for propane here. Let's say if it is for butane, so combustion enthalpy is delta H theta 1, which is 1222 minus 1122 kilojoule mole minus 1. Right. Same way for propane here. Now I'll give you the short method. Right. Now you can understand that's a long trick to go move and get the answer here. So I'll give the easy method here. Okay. Now see. Now propane means C4. It's 10 now plus 4 plus 10 by 4 here. 10 by 4 O2 under combustion gives 4 moles of CO2 gas and 5 moles of H2O. So C4H10 gas reacts with 13 by 2 moles of O2 gas to give 4 moles of carbon dioxide gas and 5 moles of H2O liquid. Now see here they have given the enthalpy changes now. They have given the delta H theta F for carbon dioxide, water and butane. So for butane, you have minus 126 kilojoule mole minus 1, right? And for carbon dioxide, we have minus 394 kilojoule mole minus 1. And for water, minus 286 kilojoule mole minus 1. Now see here, to get the answer for this, let's say this one delta X theta 2. So if you can subtract the summation of reactants minus the reactants of products, right? Minus the summation of products, right? Sorry. If you are able to subtract the summation of enthalpy changes of formation of products with the summation of enthalpy changes of the reactants, you can get the enthalpy change for the reaction here, because they are given all the formation of the formation enthalpies for water, carbon dioxide, and the butane of. So see here. So delta X theta 2 is equal to summation of delta X theta products minus sigma, that means summation of delta X theta formation enthalpies of reactants. So this is equal to, here for 1 mole 394 kilojoule per mole, right? So here you have 4. So minus 394 kilojoule mole minus 1 into 4 plus 5 into minus 286 kilojoule mole minus 1, the big bracket, minus bracket minus 1 to 6 kilojoule mole minus 1. Right? So this is equal to 394 into 4, 16, 7. So minus 1576 kilojoule mole minus 1 plus minus 286 by 1430 kilojoule mole minus 1 plus 126 kilojoule mole minus 1. So the final answer is going to be minus 2880 kilojoule mole minus 1. Understood? This is the way you need to answer the essay part here, right? So here you need to take a consideration part here. You need to consider certain things here. So it's this. First things first, you need to give the equation. So we get a marks here. So you need to give the current parameters here. Here you have the kilojoule per mole. For all these we have marks. For writing each of these enthalpies and their multiplication here, you will get a mark. Then finally, after the final simplification, if this is correct, for this number you have marks, and then if there is units, then there's going to be another mark. So here, not only the numbers, also the parameters that we are using here, the kilojoule per mole, those units must be there while you're writing the equation here, right? So first step, after writing the equations and all, you have to give the substitution here. You need to substitute, don't simplify here. Write the substitution here. Then in the next step, give the final answer. No need of writing this also. It's just for my easiness, so like it's did the same way. The final step, give the final answer. No harm in it. So you get this one a marks, and then for this parameter also you get a marks. Understood? There is a small error here. It is small summation problem here, right? So it has been 222. Okay, guys, see here, I just take the summation problem here. Just be minus 222 kilojoule per mole. So this is the part here. Right? Even you can use enthalpy level diagram also. There is marks also there. So any of the three, like you like this also you can do. At the same time, you can do with the Heslow thermodynamic cycle, or else you can use enthalpy level diagram. So now let's go to the second sub question, right? See the second question. Calculate the amount of heat needed to increase the temperature of 400 grams of water from 25 degrees Celsius to 85 degrees Celsius. Heat capacity of water is to 4.2 joules per gram per degree Celsius. Now see here, it is a simple equation, right? A simple concept here, just like physics heat. So You can use Q is equal MC delta theta or MS delta theta, whatever it is. So Q is equal, I'm using MS delta theta. So mass of water is 400 grams into specific heat capacity of water 4.2 joules per gram per degree Celsius into temperature difference here. If they get the temperature difference here, they have given what? There was an increase in temperature from 25 degrees Celsius to 85 degrees Celsius. So final temperature minus initial temperature. So therefore, 400 grams into 4.2 joules per grams per degree Celsius into 60 degrees Celsius. Right? So if you multiply 400 with 6, 2400, then it's 42. So 100,800 joules here. So if you convert them to kilojoules, it will be 100.8 kilojoules of heat is required to heat up 400 grams of water from 25 degrees Celsius to 85 degrees Celsius. So this much of energy is needed here, right? That's the second question. Now following up, let's see the third question. Assuming complete combustion would take place, right? That means there's no any partial combustion here, right? So if you take propane, it completely burns to give carbon dioxide and water completely, and same say applies for the butane also. Calculate the mass of CO2 emitted. Calculate the mass of CO2 emitted in each case when the above process is carried out using propane. First question is propane. Propane as a fuel. Now see here, there has to be an idea here, right? Now see here. So for propane, the enthalpy change delta X theta 1 was 2222 kilojoule per mole, right? 2222 minus 2222 kilojoule per mole. If you see the formation enthalpy of carbon dioxide, carbon dioxide gas, that is minus 364 kilojoule mole minus what? Right? 394. Sorry. Now see, let's say now we need to find out the number of moles of carbon dioxide, right? This is see here. Number of moles of CO2 gas formed by burning propane as fuel. So, for 1 mole of combustion enthalpy of propane, 2222 minus 2222 kilojoule is required to burn the propane here. So therefore, how much of CO2 is formed? So number of moles of CO2 formed by burning this much amount of propane from the combustion itself. So therefore, I will simplifying this using a calculator. So the answer is going to be 1.7 into 10 to the power minus. Wait a minute. Oh, I did a problem here. There's a problem. Now see, now you need this much of energy for what? Now you need this much of energy to burn, to bring the temperature from 25 degrees Celsius to 85 degrees Celsius here, right? So let's say number of moles of propane required to raise the temperature of water, right? So therefore, 1 mole of propane, it gives 2222 kilojoules of energy. Therefore, for 100.8 kilojoule, once you have this much of, if you need this much of kilojoule, then you can find out the number of moles of propane needed. Then you can go and find out the moles of carbon dioxide, then for the mass. So therefore, by substitution, we can get the answer as So I get 45.3 into 10 to the power minus 3. To the power minus 3 moles. This much of moles of propane is required. So C3 H8 now. So therefore, number of moles of CO2 required 45.3 into 10 to the power minus 3 moles into 3. Because according to the equation, for the previous equation, it was 3 moles of carbon dioxide. So 9. So 135.9 into 10 to the power minus 3 moles. This much of moles of carbon dioxide is produced. Right? So mass of CO2 is equal, W is equal moles into molar mass. So 135.9 10 to the power minus 3 moles into 44 gram mole minus 1. Right? Sorry guys, there is some simplification problem there. So I was just using the calculator there. So therefore, by seeing here, we can multiply this one here, right? So by further simplification there, one three 5.9 into 44. So nearly 5.97 grams of CO2 is released, right, during the combustion of propane. Understood? The same way goes to the second question, butane as fuel. So number of moles of butane required to raise temperature of water. So see here. So for 1 mole of the combustion, you need 2,880 kilojoules. Then for 100.8 kilojoules, understood? You need to use the fuel to just heat up the temperature of 400 grams of water. So therefore, you will get 35 into 10 to the power minus 3 moles of butane burned here, right? So number of moles of CO2 formed 35 into 10 to the power minus 3 moles into 3. The answer is 105 into 10 to the power minus 3 moles here. So mass of CO2 formed is equal W is W into moles into molar mass here. Moles into molar mass. So therefore 105 into 10 to the power minus 3 moles into 44 gram mole minus 1. So so 4.62 grams of CO2 is formed here, right? So this is the answer for the third question. Got it? This is the answer for the third question here. Now let's see the fourth one. Based on your calculation in third above, identify which fuel is more environmentally friendly and explain why it is so. Right. So according to the environmental concept of chemistry, so the one which releases more carbon dioxide causes which releases more carbon dioxide will be the causative agent for the global warming there. So once you see the combustion for once you see the mass of carbon dioxide formed by between propane and butane, you can see that the butane has low amount of carbon dioxide formed here than the propane here. So the reason behind this because the amount of carbon dioxide formed by butane is less than that of propane during the combustion. So, so butane is environmental friendly. Understood? So butane is environmentally friendly due to less production of carbon dioxide. Instead of less, you can use lower production of carbon dioxide than propane to the environment. Right? So this is the past paper question for the year 2030. Right? So very simple there. Nothing more complicated. Just to have a normal idea. Right? There's nothing complicated here. You need to understand what's the concept behind it. That's all. And then by a month's practice, you can get the answers regardless how much the question is tough enough, right? Right. Now we'll see the year 2014. Right? We see the year 2014 energetics part. 2040 analytics. So sixth question B part, right? So we'll see what the question is. Now see here, enthalpy and entropy data for the dissociation of weak acid HA are given below. So they have given HA aqueous, which dissociates to A minus aqueous and H plus aqueous. They have given the enthalpy as data H1, which is equal 1 kilojoule mole minus 1. Then you have entropy change also. So it applies continuously. So now we'll see what's the first question, right? The first question is like, write the balanced chemical equation for the dissociation of HA in gas phase. Write the balanced chemical equation for the dissociation of HA in gas phase. Now see here. Now let's say if certain amount of HA gas is gone to the gaseous phase. Now here you have HA plus. Let's say some amount of HA has gone to the gas phase here. So HA, they have given equation here. So HA dissociates to give H plus aqueous and A minus aqueous. So what will HA give? HA gas will give. That will give the same product here. So what will be the answer? HA gas. Here, physical state is important, because they are asking for the gaseous state. So you need to give the simple gas here, right? You need to show the physical states here. Otherwise, there is no marks, right? So HA gas dissociates to give H plus gas and A minus gas. So this is going to be a best answer. The equation is balanced here, right? Let's see for the second question. Right. Calculate the following for the dissociation of HA in gas phase. So now they are asking to calculate the dissociation of HA in gas phase. Means this equation, they're asking this one. For the first question, enthalpy change. Then second question, entropy change. Then third question, Gibbs energy change at 300 Kelvin. So you need to understand that they will give the standard state here. So they have just given delta H1 map. So you cannot use delta H theta. If you're using delta H theta, there won't be any marks. Maybe because they didn't give at what case this dissociation state is taking place. They have just given at 300 Kelvin. Standard temperature is 25 degrees Celsius and 1 atm pressure. 1 atm pressure only. This delta H theta can be used. Otherwise, you have to use delta H only, right? Now, see for first question, they have asked the enthalpy. So, when it's A aqueous dissociates to give H plus aqueous and A minus aqueous, it gives 1 kilojoule mole minus 1 of energy, right? Energy is being absorbed here because positive enthalpy change. Now see, this is taking place for HA aqueous. Now, while you are looking at the table, you can see A minus aqueous from gas phase to aqueous phase change. There is an enthalpy change. Same way for H plus and then for HA. Now see, they're asking the question for this now. So it's a gas. Let's say this one is delta H theta. Roman number one. Roman number one. So it gives H plus gas plus A minus gas here. Right? A minus gas here. Now so this is delta H1. Now see here, they have given the enthalpy change for A minus gas, anion gas to aqueous. So gas to aqueous they have given enthalpy. Same way for this. Same way for this. Yeah. So this one is delta H4. This one is delta H3. And finally, this one is delta H2. So you need to find delta H1 here. So they have given delta H2 minus 200 kilojoule mole minus 1. Delta H3 minus 1100 kilojoule mole minus 1. Mole minus 1. And finally, HA aqueous. So minus 150 kilojoule mole minus 1. Now see, using the thermodynamic cycle only I'm going to do this because different changes are happening now. Now see here, according to Hess law, the total summation must be equal to 0 because to find out the enthalpy change, we are doing this within a closed system where the heat is not going to be transferred either to the environment or no, the heat is being absorbed into the system from the environment. So we are doing this and just like an isolated system, like there is no contact with the environment or from the environment. So therefore, the total summation of energy must be equal to 0. So according to Hess law, so I'm taking the clockwise direction as plus. So delta H1 plus delta H4 minus delta H3 minus delta H2 minus delta H Roman number 1 is equal to 0. So you can bring this delta H1 to the opposite side. So delta H Roman number 1 is equal to, so what is delta H1? 1 kilojoule mole minus 1 plus bracket minus 150 kilojoule mole minus 1 minus bracket delta H3 minus 1100 kilojoule mole minus 1 minus bracket minus 200 kilojoule mole minus 1. So delta H Roman number 1 So I give you the final answer. So the answer is plus 1151 kilojoule mole minus 1. This is going to be your answer, right? So this question is regarding the enthalpy change of dissociation of HA gas in the gaseous phase, right? Right. Now the same case, just like this Hess law, you can apply the same thing for the second equation. So similarly, delta S1, right? Same way you can apply here. This one will del, let's say Roman number 1. So delta S1 plus delta S4 minus delta S3 minus delta S2 minus delta S Roman number 1 must be equal to 0. So delta S Roman number 1 is equal to, so here they have given 95 joule per mole per Kelvin plus bracket minus 100 joule per mole per Kelvin, then minus delta S3, so minus 1200 joules per mole per Kelvin, right? Minus 2000 joules per mole per Kelvin, right? Per Kelvin. So delta S1 is equal to right. So the answer is going to be plus 3195 joules per mole per Kelvin here, right? This one is going to be your answer here. Right, let's see the third question here. Gibbs energy change at 300 Kelvin. Right. Now you know the equation delta G is equal to delta H minus T into delta S. Right? Delta H into T into delta S. Now delta G is equal to, now you know delta H. Delta H is 1151 kilojoule mole minus 1 minus, now temperature. Kelvin temperature is 300 Kelvin into delta S 3195 is in joules per mole per Kelvin. Now I'm dividing by this total thing by 1000. So it will become kilojoule. Understood? So delta G is equal to, so 1151 kilojoule mole minus 1 minus 958.5 kilojoule mole minus 1. So delta G is equal to minus 192.5 kilojoule mole minus 1. So this is the answer for the Gibbs speaking energy. Right. Now let's see the third question there. Now let's see the third question. Comment on the spontaneity of the dissociation of HA in the gas phase at 300 Kelvin. Okay. Now let's take the third question here. Now you guys should know spontaneity of a reaction is usually considered using the delta G here, right? Using the delta G only, usually we consider the spontaneity here. So therefore, when delta G is positive, what we will say? When delta G is positive, it is non-spontaneous. The reaction is non-spontaneous. When delta G is 0. We consider them as equilibrium system, right? Equilibrium system. When delta G is negative, it is spontaneous. Understood? Now the answer is negative here. So therefore the reaction is spontaneous. So therefore you have to comment. That means you have to give a sentence. So the dissociation of HA gas in gaseous phase is spontaneous. Is spontaneous. That's all. Now see the next question. Calculate the Gibbs energy change for the dissociation of HA in the aqueous phase. Already they have given all the things here. Dissociation of HA in the aqueous phase at 300 Kelvin. So for delta H1, that's the one they have given. So that is 1 kilojoule mole minus 1. Second thing they are given delta S1 entropic change, that is 95 joules per mole per Kelvin. Now dissociation of HA in aqueous phase, now entropic change. So delta G1 is equal to delta H1 minus T into delta S1. So delta G1 is equal to 1 kilojoule mole minus 1 minus temperature is 300 Kelvin into 95 joules per mole per Kelvin. So if you divide this whole thing by 1000, it becomes kilojoule. Understood? So delta G1 is equal to so the final answer is going to be minus 27.5 kilojoule mole minus 1. Simple. Easy answer. Wait for both. Right, now let's see the next question. Fifth one, this is the last part. So at what temperature does the Gibbs energy change of dissociation of HA in gas phase become equal to its Gibbs free energy change of dissociation in aqueous phase. At what temperature? So here you need to take a small assumption here, right? You need to take a small assumption here. Now see here. Now see here, they're asking the temperature. So therefore, you need to consider that, let's say if the dissociation enthalpy of gas, let's say delta G, that same delta G must be there for the other case also. So here, independent to the temperature, they have given at the last part of the question, assume that delta H and delta S are independent of temperature. So when there is a different, when there is a temperature change, only Gibbs free energy will change accordingly. So they are asking at one temperature, no. So therefore, keeping the temperature constant, right? Keeping the temperature, like you're going to change the temperature and bring it back to the same. We're going to bring everything, the delta G to the same. But the delta H and the delta S will not be depending on the temperature. So they'll be constant there. So for example, now see here. Now we took delta G1, delta G1 we use delta X1 minus T into delta S1. In other case, delta G is equal to delta H minus T into delta S. So if these two are equal, here the temperature, here the entropy changes should not change. Understood? So therefore, if you take this one as first equation, it's then a second equation. You can equate them. So first equals second. Absolutely the same. So delta H1 minus T into delta S1 is equal to delta H minus T into delta S. So make this one as a subject. So T delta S1 minus T into delta S is equal to delta H minus delta H1. Wait, there's a T into delta S1 S minus T into delta S1. Yeah, this one will go out to the opposite side, this one will come to the other side. So this one will be minus here, right? Now you can take common here. So T bracket delta S minus delta S1 is equal delta X minus delta H1. So T is equal to delta H minus delta H1 divided by delta S minus delta S1. So T is equal to, we calculated delta X, Roman number 1, right? We calculated delta X. Yeah. The answer is 1151 kilojoule mole minus 1 minus 1 kilojoule mole minus 1 divided by, right? So delta S minus delta S1. So delta S1 is 95 95 joules per mole per Kelvin And here we calculated. So we calculated 319.5 joules per mole per Kelvin, right? So you can give the substitution here. So T is equal to, we separate 1150 into 10 to the power 3 divided by, so 319.5 minus 95. So 224.5. Here we have the Kelvin. So temperature is equal to 1150 divided by 224.5. So finally you'll be getting the answer after area simplification. But we'll get around 370.9 Kelvin here. 370.9 Kelvin. Got it? So easy case here. So here you have to imagine that you have to take an assumption that by bringing the temperature same on both, if you are bringing the delta T same here, temperature will be also same here. So therefore, the change between delta S1, delta X, and delta S should not be different. It has to be the same. Sorry, it has to be constant. There should not be any change in it. Okay. So that's the case here. So, we'll take a half an hour break, and later on we'll continue with the rest of the essay parts. And 2014 paper is getting over. The section part essay is going to get over. So we will see. Right, after the break, now let's see the next year. Next year, past 2015. Right. So 2015 essay, fifth question A part. Question A part. Right. So I'll be reading out the question. See. Consider the following reaction at a temperature of 25 degrees Celsius. AB solid reacts to form, dissociates to form C solid and D gas. The following data are given for delta H theta formation and S and S theta at 25 degrees C. So they have given a table to do it so. And the first question for this is show that the reaction is non-spontaneous at 25 degrees C. Right. Now see here, as in the previous year, like 2013 or 2012, we did a thing like they have given the enthalpy change of formation. So what we did the summation of products minus summation of enthalpy change of formation of reactants. So in that same way, we can do it here also. So the reaction proceeds like this. So AB solid dissociates to give C solid plus E gas. Now the enthalpy change for AB solid formation is minus 1208 kilojoule per mole. For C solid, it is minus 600 kilojoule mole minus 1. Then for D gas, it is minus 500 kilojoule mole minus 1. Right? Mole minus 1. So enthalpy change of reaction is equal to summation of delta H theta formation of products minus summation of delta H theta formation of reactants. This is equal to, in products we have minus 600 kilojoule mole minus 1 plus minus 500 kilojoule mole minus 1 minus minus 1208 kilojoule mole minus 1. Right? This is the one we have done in the previous year 2013. I think so. So the final answer is going to be plus 108 kilojoule mole minus 1. Same way, the enthalpy change, let me like a reaction again. AB solid gives C solid and D gas. So here the entropy change is for AB solid is 100 joules per mole per Kelvin, Then for C, it is 50 joule per mole per Kelvin. Then for D gas, that is 170 joule per mole per Kelvin. So, as in the same way, entropy, not entropy change, entropy of reaction there has to be entropy change actually, right? Entropy change, right? Entropy change of reaction. So delta S theta, right? Delta S theta, that is going to be equal to summation of S theta products minus summation of S theta reactants. So if you can equate them, 50 joule per mole per Kelvin plus 170 joule per mole per Kelvin minus bracket 100 joule per mole per Kelvin, right? So final answer is like plus 120 plus 120 joule per mole per Kelvin. Now they have asked to show that the reaction is non-spontaneous. To show the spontaneity, we know that Gibbs free energy shows the spontaneity of a reaction. So if delta G is positive means it is non-spontaneous. When delta G is 0, it is in equilibrium. When delta G is negative, it is spontaneous. So you need to show that delta G is positive. Understood? So delta G positive means that is non-spontaneous. So Gibbs energy change. So delta G is equal to G theta is equal to delta X theta minus T into delta S theta. So delta G theta is equal to enthalpy change is 108 kilojoule mole minus 1 minus the temperature is 25 degrees Celsius, which means 298 Kelvin into 120 joules per mole per Kelvin. Total, if you divide them by 1000, given kilojoule. So therefore, here Kelvin will get cancelled. Kelvin per Kelvin get cancelled. Finally, we are remaining with joules here. So by simplification, so we will get your answer. Delta G theta is equal to positive 72.24 kilojoule mole minus 1. Hence, prove. So therefore, so another statement you can write. Therefore, the reaction is non-spontaneous. Therefore, the reaction is non-spontaneous. So when we give the statement for that also we have marks. Understood? For that also we have marks. Right. Right. Now let's see the second question. This reaction is spontaneous when the temperature is greater than T degrees Celsius. Understand? This reaction is spontaneous when the temperature is greater than T degrees Celsius. This reaction is non-spontaneous. Again, when the temperature is less than T degrees Celsius. Understood? So here you need to consider that the reaction must be in equilibrium. It has to be in equilibrium. So you need to find out the T. No, they said it will not go beyond the. It won't be spontaneous. It won't be spontaneous when it is below the temperature T degrees Celsius or greater than. It will be spontaneous at higher temperature than T degrees Celsius. So here delta G must be what? Exactly 0. So at this point only you can find out the temperature here. So delta G is equal delta H theta, right? Delta H theta minus T into delta S theta. So delta G is going to be 0. So 0 is equal to, we found out delta H is equal 108 kilojoule mole minus 1 minus T degrees Celsius. That means if it is degrees Celsius mean you have to convert this one to Kelvin. So you have to add this by 273. Understood? This is Kelvin temperature meter into 120 joule per mole per Kelvin. If you divide this one by 1000, you can get kilojoule. Right? You can get kilojoule. So so by simplifying, T plus 273 into 120 over 1000 kilojoule mole per Kelvin is equal to 108 kilojoule per mole. So here this whole parameters will be cancelled here. Only per Kelvin will remain. So this 0 will go. Here will go 9 times, right? 12 into 908, 9 times. So T plus 273 is equal 900. So T is going to be 627 degrees Celsius. Or you can give us 900 Kelvin, not an issue. Instead of putting you reading there is here degrees Celsius, so that's why I took 273. You just take T, you will get the answer directly as 900 Kelvin. So that's not a problem here, right? Both of these answers are correct, right? So state the assumption you made in the calculation in second one above, right? As in the same way, the last past paper we discussed, but they gave a note like delta H and delta S is independent of temperature. So at that instant only you are going to calculate. We equated the delta G to find out the exact temperature there. The same case you can apply here. Why? Because what did they say in the second question? That the reaction is spontaneous when the temperature is greater than T degrees Celsius. Right? It becomes non-spontaneous when the temperature is less than T degrees Celsius. That means once you're changing the temperature, Gibbs free energy will change. Understood? So Gibbs free energy will change as a result of the multiplication of T into delta S. So entropy and all will change there. So since those parameters depend on temperature, there is a need to keep the delta H and the delta S as constant value. So then only you can find out the exact temperature at which this reaction can take place. So in that case, delta G must be 0. So what is the assumption we need? The delta H and delta S are independent of the temperature. Here you guys need to know in each, by doing conceptually, by each consecutive past papers, once you're doing them up, you will come to know there are certain points that you have to remember. See, so we did last year past paper, like last year past paper, 2015. So the previous year we did 2014. In that, they gave a case. So that case is like you need not to consider the temperature dependency on delta H and delta S. So once we came to 2015, they have made that one as a question. Understood? The note became a question. As a result, you can generate your own ideas. Like you can understand what is happening here. The way you have to approach will be different. Depending upon the type of question, the concepts will be the same. Concepts, of course, will be the same. The way of approach will be different. So the way of approach is the most important part, then the conceptual part. In concept, you can directly refer it from resource book or get it cleared through by doing MCQs there. That is not an issue. But once you're approaching the essay, you have to get a clear idea, like how can we do this step by step? What is the main parameters needed for this? How can we simplify it quickly? So within those practices only, all these question, the way of answering, the accuracy, the value changes can be correct, right? At most of the situation, it will be correct. So this doesn't matter for the organic chemistry, inorganic chemistry. Those cases are very different. But in inorganic, we have calculation parts. So in calculation parts also, we have to be a little bit more accurate. So then only you can face the paper in an easy way. So there is nothing harder here except and until you do hard work and practice. right? Then only you can get all these ideas here. Got it? Right. I have come to a decision like now I'll stop until here because after that we have around 5 or 6 years. So if we have time, we will check them out. We plan to do certain term papers, final year papers and all from Royal College, Visakha schools and all, Ananda College and all. So those papers have lots of challenging areas where you have to know the way of approaching it. So we'll try those papers also. So I'll be stopping from here and according and I said I will be discussing about the class fees details also, right? So I'm planning to charge per class 400 rupees. So I'll be doing 8 classes per month. So nothing harder. I just need you all guys to pass the exam. That's it. There is no mean of getting profits from here. Practice yourself. Be motivated. You can do, guys. Nothing is impossible here. So from here, we'll meet you in the next coming Wednesday. Thank you very much. Goodbye.